If you didn't know, Arena has some really interesting example files which you can look through and learn from them. Today, I want to talk about one of these, and if you want to open it, it's through File, Browse Examples. I'm talking about the assembly line file. This is really interesting because it has stations and conveyors, two things which might be new to you, as well as some other more basic things, with an entire slew of animations going along too. After watching this video, you should be able to understand and duplicate from scratch the example file I'm going to look at and understand how a lot of the different blocks work. Let's go ahead and get started. This is really interesting because it has both physical animations at the very top and some different metrics, which might be more useful if you're presenting this to somebody else. If you're doing the analysis yourself, maybe you don't need the visuals here and the logic below is good enough for you. What I want to do and what I find most helpful in these cases is to go through the animations, watch what's happening with the entities, and then once we see that, go through the logic, understand what's happening with the blocks, watch entities moving between blocks here, and then go back and look at the animations again. So let's get started with that one. If I jump into the run, I'm going to jump the speed down to the very lowest setting so we can have more time to talk about what's going on and really make sure we get a detailed look at this. We can see that things are coming into a conveyor belt system. There's one box coming into station 1. When the operator is busy, it turns red, and we'll see more and more things arrive as we do that. Jumping the speed just up a little bit further, we can see that there are a few other boxes which start to arrive. They're all on the conveyor belt and are moving independently on this one, which is pretty interesting. I will mention that conveyor belts get a lot more complicated than this one, and there could be a separate hour-long video lecture on just this topic. We'll hold off on to going into too many of those details for now, but it is pretty cool to see what it looks like. We can also see that in the logic modules, things are pretty similar, so station 2, 3, 4 all look relatively similar. There are actually 5 stations here because the entrance to the conveyor does count as one, so you will need to consider that. The other thing that's going on here is some attributes and some variables, which are used to display such like the WIP, the average cycle time, which we'll get into how those are created, relatively simple through the assignment thing at the very top. Let's now stop this and take a look at each of these different modules, zooming in so that you can see a little bit more about what's going on with this one. The create module is nothing too exciting. It's really just creating one part at a time, infinite number of variables, subject to a normal distribution, which is relatively straightforward. Once entities arrive, they're going to move forward with no simulation time passing. We haven't had a delay or a transfer or anything yet into an assignments module. This assignment is following a really interesting convention, and we'll take a look at how these are used at the very end of this module look through. The interesting convention is that it has a variable and an attribute. The attribute has attribute underscore, the variable has variable underscore. Seems relatively straightforward. I'd encourage you to use that in your own models as well. Taking a look at the variable one, what this does is it counts the number of items in WIP. Every time you have an entity arrive to this at the start of the process, your WIP increases by 1, which is what happens here. VWIP equals old VWIP plus 1. You'll see at the very end, when something's leaving, the VWIP will equal VWIP minus 1. Taking a look at the attribute example, this just saves an attribute called a underscore time in equal to the Arena syntax of tnow. Tnow just gives the current simulation time. Later, we can take the simulation time when it leaves, subtract that with a time in, which is tnow when something enters, to see the total time in system, or TIS. Seems relatively straightforward. We'll get to that at the very end. And now that you've seen this, you can start to use it in your own different models. Now we get into some of the new items, which is the station entrance. Station entrance right here is really just an attribute which will tell the entity you are now at station entrance. You could name it station 1, station Paul, whatever you really wanted to name it is what you can do. This is combined with a material handling block right here, so blue is in the material handling section, and this is an access module to get onto a conveyor. Conveyors do get pretty complicated. We're not going to go too much into detail right now, but we've given this a name, auto parts belt, just have one cell, and we have a queue to get into the conveyor. This means that you're never going to really be blocked later on, and there's really just going to be a queue at the very start here with nothing else really happening. Don't need to worry about that later. We're actually going to see that there are going to be no queues forming at each of these different operators, which is kind of the power of this conveyor, and it is pretty interesting. The next thing is, again, a little bit different because we now don't have a connection between the conveyor and anything else. Instead, what this conveyor does is just sends everything to post 1. I think having post here is a little bit confusing, so I might just call it number 1 instead of post 1. So once it goes to the entrance, it now goes to post 1. Now we should look at the conveyor material handling information in order to understand what's going on here. We do have several different conveyor posts. Each of these are a station, so station 1, station 2, station 3, station 4, etc. And if I actually look at these distance attributes right here, nothing there. Network really won't have anything. Transporter is a little bit different than conveyors because those can go in two directions. But if we actually look at the conveyor, this is where something is new. We see that this is an accumulating conveyor, which means that it keeps moving regardless of anything. It doesn't have to stop to let something on or off. That would be a non-accumulating conveyor, which is a little bit different. It also moves at 300 units per minute, and the cell size is 1. If you wanted to have a few different options, you could increase the cell size, increase the max cells occupied. And again, that's a subject for a different video, but if you try and increase a few options, you'll have to change a few different things here. And we are going to see that report statistics is checked. However, in order to see this, you need to go to Run Setup, open that, click Project Parameters, and make sure that Conveyors is selected to actually see that in the report. Just something to note there. You can also see that for a few different options. If you start to use transporters, tanks, and other simulations, that could also be pretty important. Okay, now that we understand that we have a station, the station leads into an access point to the conveyor, and convey post 1 tells it to move to station 1. What happens when it's actually at station 1? And what you'll see is that the entity will sort of disappear from post 1 and move directly to post 1. There's no connection between these. It just knows that we're moving it to station post 1 because that's the name of the next station module. So that should help explain some of that. Once it's at station post 1, it's then actually going to have a delay for the first time in the entire simulation so far. It's a normal delay. In other words, it is a seized delay release, a normal station, normal processing, I should say, where the operator works on this for a normally distributed time according to 2 minutes, which is, if you notice, is less than the arrival time. It has to be less, otherwise we'd end up with an infinite number of parts ending up in the queue here. Just something to pay attention to. Once we go through that station 1, now we need to move the object from station 1 to station 2. And that is done through another conveyor module right here. So this is convey, and it's telling the conveyor, move it to station 2. That's all this is doing. And again, because the conveyor is doing the moving, I don't have to connect this with any sort of different connectors, etc. I can just go down directly to station 2, and this is the station module saying that this is where it exists now. Moves into a standard seized delay release, same as the first one, except operator 2 is being worked on instead. And when it's done with 2, it moves to 3. When we're at station 3, the operator works on this in station 3. This is the processing step, seized delay release with operator 3. Now we have a decision module. We could be completely done, and let's go through that track first. It will happen 10% of the time. And if we are done with our product, it's ready to ship, now we have to make sure that it leaves the conveyor. It does this through an exit module, which is relatively straightforward. It just exits the conveyor. Once something exits the conveyor, we can count the products. So we'll count products number 1. Then we will change our whip. If you remember earlier, our whip was equal to whip plus 1. Now our whip is equal to whip minus 1 because we have something leaving. And again, it's using the same variable name because it's the same variable we're looking at. We can also record the cycle time. So the time interval is the definition being used here, which gives the difference between t now and whatever attribute we point it to. And the difference between a underscore time in and t now will be the time in system, or how long the entity has been in the system. And then, of course, after that, we have to have a dispose module, which is relatively straightforward. In the other case where something does not finish after number 3, it now moves to number 4, which is another convey module. Looking at number 4, we can see that there's station processing with operator number 4, and then finally counting the same count right here. You could switch the order on these. You notice that we have count and then exit here, but for number 3, we have exit and then count. That really shouldn't matter too much because there's no time difference in terms of the simulation between these. There's no delay between these options. It's not like we're taking time to count it, taking an operator to count it. This is just the simulation recording it. Of course, we also have to record the cycle time, which is the same as before, as well as remove or decrement the WIP by 1. And of course, we finish with a dispose. Okay, that was a lot, but now when we watch the simulation and go through step by step, we should be able to understand what's going on in a little bit more detail. I'm going to scroll up right here, and you're not going to be able to see everything going on because there's a lot of stuff going on here, and the screen is not very big. So I want you to just pay attention to the entities on the top and match them up with the entities on the bottom of where something is moving. So we'll try and see what we can do here. And once we finish this, I'll go through each of these animation blocks, how to add the operators, how to add each of these different station identifiers, for instance, and even the attribute examples, KPIs, simulation clock, whatever you really want to call it. Let's go ahead and get our model running. I'm not going to run, instead I'm just going to press step. What we see is that now we're starting. If I click through one more time, the next event which occurs should be one part arriving. We should see this 0 change to a 1, which let's go ahead and see that. Yep, we do, and you saw a box move from arrival to assignments. Once we get into assignments, the clock is still not going to move, but we are going to have the WIP go up by 1 because WIP is equal to 0 plus 1, which is 1. Now we move to the station entrance, and now we need to go ahead and click one more to get into entering the belt and actually moving it to this entrance portion right here. Once that resolves, we should see that yes, we are at the entrance. Now we need to convey this from the entrance to station 1, which you can see happens. It does happen really slowly because I've slowed the run all the way down so that you could see. At this point, the entity is now going to move from convey 1 to station 1, which we should still see happens. It does that. It then moves from station 1 to post 1, and now we can start the seize delay release process. That means that the operator is going to be seized. You can see that some time has passed, and that was the time spent moving between entrance and station 1, which you can learn a little bit more about with conveyors. And conveyor speed and distance, of course, would go into that, which is really just cells per time. Now the operator is seized. We can click step one more time and see what happens. It could be this one finishing, or the other thing that it could be is a new part arriving. It's random, essentially, in terms of what happens next. Looks like it was the release that happened next. It's now hit convey 2. We should see this pop down and start with station 2. So this moves from station 1 to station 2, which, if again we zoom out just a little bit, you should see takes some time to have happen. Now we have a new part arriving, and the same process is going to occur where it moves between each one of these. You saw WIP go up when we hit assignment. We get to enter the belt, it shows up, and now we have convey between entrance and 1. Notice that this convey moves both of these things at the same time. If you change the number of cells between these, for instance, you could see a few other interesting things happen. Now we have the part at station 2. It's actually going to arrive at station 2. The next step should be a seize, which is what we see happen. I'm going to stop going through everything just individually and now start just running it at the slowest speed possible so that you can see something going on. Could be some interesting things. Again, it takes a long time for this animation to move here, but it's not too bad. There's nothing too crazy going on. I'm going to speed this up just a little bit, and you can see a few more things happening. You can see things moving back and forth, and we can see that there are never any queues forming at station 1 because it's on a conveyor belt, which is why this is all done instead of just being connected directly with smart connectors, although that's a little bit of an oxymoron. Jumping a little bit forward, we can see that yes, this continues to run, our whip is increasing, our average cycle time only exists when something finishes, which we now have 2 objects which have finished. Let's go ahead and let this run for a little bit further until we can check the results and what this looks like at the very end. This is going to do 10 different replications, which will be a lot, but you can see what's happening at this point and when operators are being seized. Something is just left on the conveyor. So when there's 2 of these objects, they're left on the conveyor, which means that physical space is being used, but the operator doesn't actually have anything being used in the queue, which is pretty interesting. And you can see that, we'll finish replication number 1, move on to replication number 2, and be able to get a few different details from this. If I go ahead and click the fast forward to skip all the animation and just do the calculations, we can now look at the results and see what's interesting about any of those, which there should be a few different things. I'm going to go ahead and open the results. I'll have to change my setup. This is a bug to look at the report in Notepad versus just the and I'll have to run this again here. Known bug, a little bit annoying, but not the end of the world. And this is, if you are using an older version of Arena, you likely won't run into this issue, but you won't have as many options. It will look a little bit different from what I do, although the math behind all of this is the same, and animations, of course, don't change the math that goes on behind all of this. Once we look at the report, and I'm interested in the very bottom section, which is the summary of all 10 replications, we can see that there are a few different interesting things down here. We have the number in, which is, let me go ahead and find the bottom again here. The number in, which is 160, number out is pretty close to that. That means we had 1 left in whip at the very end. We also can see how many times an operator was seized, and we should see that number 4 is less than number 3 because 10% of number 3 just passes and exits. And we can see the utilization of each one of these, which could help you make some decisions about what you should do in terms of reducing the number of workstations, combining these, or where you might want to add a particular worker. If I go ahead and take a look at just one replication, for instance, we can see that there's the cycle time, and there's a few different other options here. Notice that there is sometimes a queue for getting onto the conveyor, but once we're actually on the conveyor, there's really nothing that happens. There's not any waiting for any of 4, 3, 2, or 1. Now, if I go ahead and take a look at a few of the other statistics, which I did mention that you would need to do some changes to this. If I go ahead and click Setup, Replicator Project Parameters, I want to make sure Conveyors is checked there. I'll click Apply, and now I should be able to look at the report, which I'll have to promise one more time in order to see. I want to take a look at the conveyor information. I will note that utilization of the conveyor refers to space utilization and not time utilization. Those are very different, so it is important to make sure you understand what that difference is. It's not the most straightforward thing in the world. If I zoom in a little bit here, you can see that there are some interesting things going on. The belt utilization is very, very low, so 0.007. That's very, very low. But we can also see the length accumulated, which is, again, another interesting thing to look at. And of course, I will have a separate video on conveyors. The last thing I want to go over now is a little bit about these animations and how these were created. So you can see that total production is really just representing a variable, and the variable is equal to an expression, so NC, which is a pretty standard Arena 1 right here. You can see a few other options out there, and the build expression tool is pretty useful. Whip, of course, will just point to the variable bwhip, which is really straightforward. You don't even have to type an equal sign or anything, just put in the variable and it should come up. Average cycle time has to do a little bit of, again, this uses a standard Arena item. If you don't know what T average is or how to get that, you'll remember at this time, but you can do build expression for the average cycle time and get that relatively straightforward. In terms of these text labels, those are just entrance, station, nothing too much there. If I do go into animate, now I can see that I can add a station. So if I clicked on station, I can put a new one in here and tell it which one it is. Of course, it's not actually going to exist, so I'm going to delete that one. That's how you would get station. And the operator right here, you can add that, and you can actually, if I double click this, get into editing the entity picture in terms of what it is when it's busy, what it is when it's idle, and modify that as I see fit. I hope you did enjoy this and did learn something. If you want to see other arena simulation videos, you can subscribe for more of that. Until next time, I hope you got something interesting, and thanks for watching All About Industrial Engineering.